All right, well, welcome to Lesson 5.2, and last night we talked about multiplying fractions, so tonight we're going to focus on multiplying mixed numbers. Okay, now that will also include whole numbers, and we did see a few whole numbers in last night's lesson, so we've already kind of seen those a little bit. And I've got three friends that are going to be here to help me. You guys want to say hi?
Hi. Good morning.
Okie dokie. Let's get started. All right, so what we're going to do first, before we even get into the tricks on how to multiply mixed numbers, let's remember what we learned at the beginning of last chapter, and that is how to do estimates. Because the best way to catch a mistake is to do an estimate before we do the problem. And I want you to stress that word, everybody, before. Unless you do your estimate before you're looking at the answer you got, you're not going to do a good estimate. All right, so let me give you an example. Suppose I'm multiplying 5 and 5/6, and I'm going to multiply it by 6 and 4/9. Okay, before I even start, we already know how to estimate mixed numbers, don't we?
Before.
Before, yes, but what do we do with mixed numbers?
You round them up.
Well, we don't round them up necessarily. We round them to the what?
Nearest whole number.
There we go, the nearest whole number. So 5 and 5/6 is very close to 6, right? So we'll put a little wavy equals here. Oh, my stylus is not. Okay, wavy equals. And 6 and 4/9. Now, is 4/9 smaller than or bigger than a half?
It's smaller.
Think about everybody. While you're watching these, you think about these questions. Yeah, it's a little bit smaller. 4/8 would have been a half. It's a little bit smaller. So that one's going to round to 6 too. So 6 times 6 is going to round to about 36, right? So if we don't get an answer reasonably close to 36, we've probably made a mistake. Okay, so that's pretty much it. Don't forget to do your estimates. All right, so now that we've got this estimate up here, let's go ahead and actually do this problem. All right, here's what I want you to do for mixed numbers. The easiest way for most of these problems, at least the easiest to know how to do the problem, is to change. You can't multiply mixed numbers. Okay, you can't do it like we did with fractions. Remember when we were, remember how when we added and subtracted mixed numbers, we added the whole number part and we added the fraction part, and then we just stuck them back together. That does not work for multiplication. Okay, so if you did that on this problem, you would get 5 times 6 is 30. You'd multiply the two fractions together. You will not get the right answer. So what you have to do instead, yes, that would be the opposite of the right answer. Thank you very much, Zach. What you need to do instead is you need to multiply them as fractions, the same way we did yesterday. So what we're going to have to do on both of these mixed numbers is we're going to need to change them. Remember the check mark? We're going to need to change them into improper fractions first. Okay, so what will 5 and 5/6 become? So we multiply 5 times 6, which is?
30.
30. Okay, and then we add the 5, and we get 35 over 6. Okay, all we did was convert this mixed number down into an improper fraction. What if we do the same thing for the second fraction? A little bit harder. 6 times 9 is?
54.
54 plus 4 is 58, and so I get 58 over 9. All right? So now, do you see anything that cancels? Now, these are pretty big numbers. I don't really want to multiply 35 times 58 if I can help it, right? So what cancels? This is really important.
35 and 9.
What goes into both 35 and 9?
7. Oh, wait, no. 9.
It goes in, you're right. 37 goes into 35, but it doesn't go into 9. 9 doesn't go into 35, so I think you're stuck there.
58.
6, what about 6 and 9?
I don't think
you can't cancel side to side, right? They are both divisible by 3, but we only cancel top and bottom. However, I do see 6 and 58. What kind of numbers are they both? They both end in even, right? So at the very least, we can take out a 2. So that'll make the 6 into a 3. And what's half of 58?
28.
No.
24.
No. 29. Now, it ends in a 9, so you might think that cancels with the 9 on the bottom, but it does not. Unfortunately, 29 is prime. And unfortunately, I don't think we can cancel any more than that, guys. So what we're going to have to do now is we are going to have to show our work. And we haven't done a lattice in a while on one of these videos, so let's do a lattice here. So it's good to draw the lattice nice and neat first. You might put the top numbers on, but don't put the side numbers on until you've drawn the lattice. And we're going to multiply by 29 because we were able to reduce it a little bit. All right, so what do we get? This is going to be a little tricky for me to do with the stylus, but let's see if I can squeeze it in here. So we get 0, 6, 1, 0, 27, 45. Be careful about that 4. If something doesn't... Yep. All right, now when we add up the diagonals, we get 5, 7, 4, and 0 adds up to 11. Carry a 1. 1 and 1 is 2. Always start with that carry so you don't forget about it. Plus 6 plus 2, I think that's 10. So we get 1015. So the answer here is 1015 over 3 times 9, which is 27. Ooh, sorry.
Did you reduce that? Can you?
Now, you can't reduce it in terms of taking any common factors out. We already kind of proved that before we did the multiplication. So now what we'd have to do is we would have to reduce this to a mixed number. And I'm not sure we have enough room here, but let's try it. 1,115, and I know you guys like to do partial products division, so let's go ahead.
I think I forgot that.
I'm not sure I have enough room here, but let's go ahead and allow partial products division here, because all we're changing this into is a mixed number, so we can do an integer division. We're going to have to move some things around to make this work. Ooh.
Pretty.
Yeah, okay, we got a little more room now. All right. Oh, I just lost my 5. It went away with my problem. Let's put the 5 back in there. All right, so 1,015 divided by 27. All right, well, our estimate was 36, right? Well, let's start with 30. Well, 30 times 27, well, what's 3 times 27? Actually, that's kind of a cool one. It's 800. Wow, my stylus is not working today. 810,
right.
Which leaves me with 205. All right, that was pretty helpful.
I had a 0 if I'm
And, okay, and if 30 of them was 810, we probably need a little bit less. So let's go with our estimate. Let's assume that we were pretty close with that. Let's take 5 more out. Okay, now we're going to run out of room here. So what I'm going to do is I'm going to start putting stuff up a little higher. Let's put the 205 up here. That's how much we had left. 5 times 27, I believe, let's see, 5 times 7 is 35. So there we go. That worked out well. And 5 times 2 is 10, so we get 13. So if I subtract that now, the 5s cancel out and get 0. And 20 minus 13 is 7. We're almost there. Okay? 27 goes into 70 how many more times? Well, it's not going to quite go in 3 times, but it will go in 2 more times. That'll take out another 54, and we're going to be left with what remainder? I know this is getting a little messy.
16.
Yeah, you get a remainder of 16. So, and what do I have here by the partial quotients? Let's circle this in green. I have 35 and 2, so that's a total of 37. Agreed?
Yep.
So I get 37. I'm going to write the answer over here. And the remainder, you just said, John, was 16. And we were dividing by 27. That was not a fun problem. However, aren't we glad we did the estimate? Not only did the estimate tell us that, yeah, that's pretty close, but it also helped us when we were actually doing the hard arithmetic, didn't it?
Yep.
Now, you might look at a problem like this and think, oh my goodness, that's going to be an awful lot of multiplication and division. And for this problem, it was. But this problem was specifically designed to be really hard because it was only supposed to be an estimate.
Oh, yeah.
Now you might ask yourself, is there another way to multiply mixed numbers without changing them into improper fractions? And there is.
There is.
And so, Will, I'm going to need you to help me on this one. Okay, because this is going to be a little bit of foiling. There is another method, and it's based on something that you're going to see much later on in algebra, but this is probably a good time to see it for the first time. They can come in. All right, so if we do 5 and 5, 6, and we multiply by 6 and 4 ninths. The only other way to do this without using improper fractions is to make sure we multiply all the parts together. Well, how many parts do we have here? By parts, I mean the whole number and the fraction, the whole number and the fraction. So there's 4 parts. So there's this trick that you will learn in algebra called Foyle, and it stands for firsts, outers, inners, last. Once again, it stands for firsts, outers, inners, last. If I draw that in, it'll make a little bit more sense. So firsts, what I mean is 5 times 6 is 30. It might be on the daily quiz. The outers is the first thing and the last thing. This is the outers. So 5 times 4 ninths would give me 20 over 9 if I multiply the number 5 times 4 ninths. Okay? The inners are the inside here, the 5, 6 times 6. And what is 5, 6 of 6, guys?
5, 6 of 6?
5.
It's going to be 5. Yeah, the 6's cancel out. You get 5 over 1. Okay? And finally, let's go back to black. The lasts are these guys here. 5 6 times 4 9. So that's going to be just a plain old regular fraction multiplication. I'll rewrite it down here. 5 6 times 4 9. I could have canceled the 2, so I get 2 and 3, and I get 10 over 27 just like last night. And now to get your to get the final answer, you just add all this stuff together. All right, now the 30 and the 5 is easy to add together. That's 35. And the 29ths and the 10/27ths, they're both fractions. So to add those together, we're going to need to get a common denominator. So I'm going to change the 20 over 9 into 60 over 27. And then I'm going to add in the 10/27ths from up here. And we're going to get 35 and 70 37ths, and that, or 27ths. And that should look familiar. That was that last step in the partial quotients division.
Yeah.
We saw that 27 went into 70 2 times, right? And so this changes into 2, and our remainder was 16, you recall, over 27. And now if I add this up, I get 37 and 16 27ths. And this is called foiling, but I actually like to call this method Herald, because if you look up here at all these little arrows we draw, if you draw the firsts and the lasts on top, and you draw the outers and the inners inside, it looks kind of like a face. See the smiley face and the chin and then kind of the weird hairdo?
That's what I was saying.
It looks kind of like Zach, actually. And
do it with a binary.
yeah, and so we do get the same answer. And again, that was a very difficult problem. Now, normally when I teach something, I teach it with a really easy example, and then we build up to the hard example. So for tonight's video, we're going to do it just the opposite. We're going to start with a hard example. If you can get these down, you should be in good shape. So already, let's see, you all are actually coming into class right now, so you already caught the tail end of this video. So enjoy the rest of the video, and thanks for watching the video, and we will practice this skill in class tomorrow. And remember, we're going to be practicing estimates, we're going to be practicing by changing them into improper fractions, and we're going to be practicing by doing this FOIL method. Okay, now I recommend of those 3 methods to always do an estimate and to do the improper fraction method for most of these. All right? So we're going to call that a wrap, and we'll practice these in class tomorrow. Bye, everybody.
Bye. I like